If you've ever watched crime densities dissolve just by switching from census tracts to police beats, this episode is for you. Today we're talking about the Modifiable Areal Unit Problem, MAUP, and its more unsettling cousin, Simpson's paradox. These are analytical traps that can flip our conclusions about crime, neighborhoods, and social behavior without changing the underlying data at all. Here's the core idea. Take two analysts working with the same crime data in the same city. One maps crime using census tracts, the other uses police beats. Same incidents, same city, different boundaries. They reach opposite conclusions about where crime is concentrated. That's the Modifiable Areal Unit Problem. Your results depend on how you divide space. MAUP shows up in two main ways. First, the zoning effect. You keep the scale the same, but redraw the boundaries. Crime clusters shift because the shapes changed. Second is the scale effect. You keep the boundaries conceptually similar, but change their size. Block faces become block groups become census tracts. Patterns emerge or disappear purely because of aggregation. Nothing about the crime changed, only the map did. Now we can get more uncomfortable. Simpson's paradox is what happens when a relationship in aggregated data reverses once you disaggregate it. In spatial analysis, we often call this association reversal. The danger here isn't bad math. The danger is that both results can be statistically correct while pointing to very different stories. Consider vacant lots and burglary. At the city level, a global model might show a positive relationship. Cities with more vacant lots tend to have more burglary. That fits a familiar ecology of crime narrative about urban decline and risky land use. Vacant lots become a symptom of something larger that is wrong with the city, and it signals a risk factor for burglary. But zoom in. Analyze at the street block level. Now you might find the opposite relationship. On a given block, a vacant lot reduces burglary opportunities from a routine activity standpoint because there is no structure there to burglarize. No opportunity, no crime. So which result is right? Both. The mechanism changes with scale, and it's the essence of Simpson's paradox. At the city level, vacant lots may signal disinvestment, which is related to macro-level crime. But at the micro level, vacant lots can reduce opportunity for burglary. If you collapse those processes into a single average, you misrepresent both. We see the same thing outside criminology. In King County, Washington, researchers found that across the entire county, older houses appeared to be worth more money. That makes sense. Older neighborhoods are often established and desirable, but within individual neighborhoods where houses are otherwise similar, new homes command higher prices. If you ignore Simpson's paradox, you might conclude that house age increases value. That conclusion is statistically defensible, but locally wrong. This isn't a data error, it's an analytical one. GIS doesn't simply discover patterns, it constructs them based on our choices about scale, boundaries, and modeling assumptions. When we ignore that, our findings become fragile, sometimes misleading, occasionally indefensible. So what do we do about it? There's no single fix, but there are better habits. First, local versus global modeling. Tools like multi-scale, geographically weighted regression let relationships vary across space instead of forcing one rule onto an entire city. Second is sensitivity analysis. This should be the baseline. If your conclusions change dramatically when you change spatial units, that instability is part of your result, not something to hide. Third, meaningful spatial units. Natural or functional boundaries, rivers, street networks, service areas, these can sometimes align better with real processes than administrative units can. They're not perfect, but they're often better. And finally, simulation frameworks. Tools like AZTool simulate data at the smallest feasible scale and repeatedly aggregate upward. Instead of chasing a single true answer, they reveal a range of effects that persist across spatial choices. You can also do this manually. The deeper lesson here is simple. Space is not neutral. If we want to understand crime or any other spatial process, we have to stop hunting for a single average relationship and start asking where and at what scale the process actually operates. Because if changing your spatial unit changes your conclusion, the map isn't wrong. Maybe your question is. Thanks very much. Hope you'll tune in for the next one.